Alright, test review. There will be 20 multiple choice, 11 nomenclature, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 nomenclature. So naming, they're not multiple choice, you have to actually write the name. This includes actually naming and formula. So going both ways, going from a formula to a name, and from a name to a formula. Two problems where you have to come up with the Lewis dot. So Lewis structure. That was 3. Note there are multiple choice has some Lewis structure. So it's not like there's only 2 Lewis structure in the problem. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 problems where you have to put ionic versus covalent. Based on properties. For example, liquid. Is this a property of being ionic or covalent? Keep your mask on, Carlos. Covalent. Why not ionic? Remember, ionics are usually salts. They have an extremely high melting point. That's because they give up the electron and pull really strongly together. It's hard to separate the individual molecules of an ionic compound. So know all the properties of ionic versus covalent. So what's the difference between ionic versus covalent in terms of electrons?
It's ionic, doesn't it give all of them up to 1?
Yeah. Give up or transfer electrons, while covalent is sharing pairs of electrons. You should know your diatomic molecules. What are they? You got your hydrogen itself. Then you're going to have your L shape. Nitrogen, oxygen, fluorine, chlorine. And under chlorine is bromine. And then iodine, right? Whenever 2 elements mix together, you should be able to predict if it's ionic. So if it's ionic, the En difference will be greater than 1.7. Polar covalent. That's where it's 0.5 up to 1.7. And then non-polar covalent, which would be 0 to 0.5. So it's a spectrum. 0.5 to 1.7. Polar just means that you're going to have two sides, one more positive and one more negative. Why do things form ionic or covalent bonds?
So they could be in the most stable.
And what's that called?
Octet.
Either the octet rule or what's the other name for it? Noble gas configuration. So they're trying to become more stable by either satisfying the octet rule or gaining a noble gas configuration. So let's say element X and element Y. If we have a pair of electrons between them, we can represent this pair of bonded elements as a single bond. If we have two pairs between them, we can represent this with a double bond. And likewise, a triple bond. By the way, you can either represent with lines or dots. I prefer that for your Lewis dot, you change these to lines. On the test, on the multiple choice section, I can't put lines on them, so they will be like this. Just remember that every pair represents a bond. And what do we call, for example, these two that's off by itself?
Pairs?
What pairs?
Lone pairs?
Lone pairs. Lone pairs are electrons that aren't bonded. So it's unbonded pair of electron. The higher your difference in En, the more what you get. More polar you get. So, for example, OH versus NaCl. Which one is more polar?
NaCl.
Yes, it's even in fact ionic. It's more polar.
Or it should be like 1.4. So it'd be covalent, right?
Which one?
OH.
OH, yeah.
I think OH3.
I don't have my periodic table with me. Should be around 1.3. Know how to tell if something is covalent or not covalent? There are several questions where I ask which one of these is ionic, which one of these is covalent, which one is the most polar. What does it mean to be polar? Polar means, let me write this. Let me see if I can get it. Let me see if I can Google this. Is ionic bond a polar bond? Because usually when you say polar bond, you mean polar covalent. Is an extreme situation. Polar bonding is technically polar bonding. I should put covalent. We usually leave that off. Is when there's an unequal sharing of electrons. So, for example, in water, oxygen holds on to the electrons more than hydrogen does. So, in ionic, it's a complete transfer. We often don't say this is polar, because polar usually refers to the sharing of electrons, which means covalent. But it's the extreme case of polar covalent is where it's completely given up. It completely gives away its electron to chlorine. In polar covalent, there is a unequal sharing. It's shared briefly with the hydrogen, but mostly the chlorine wants to hold on to it. And non-polar, there's an equal sharing. They go back and forth constantly. And there's no partial charges anywhere. So on the test, I'm just going to make something up. This isn't a real formula. If I wanted to do a double bond between O and H, on the test and in the multiple choice, it would be represented like this. Because I can't do lines. But this is still a double bond. We have two pairs and two pairs. This makes the two lines. So two lines is technically 4 dots. Usually also a single line. They don't do it like this. I think I've done that before. It's usually put side by side like that. Because you usually write it on the side, don't stretch it out. questions like, which of the following chemicals have a single lone pair of electrons? What this means is that you're going to have to know how to write the Lewis dot structure and count how many lone pairs. Water has 2 lone pairs. Again, more questions like, which of the following has the most polar bond? And I will say that if it is ionic, you can consider that being more polar. Even though you wouldn't consider it a polar bond, you consider it an ionic bond. But it is still more polar. Because more polar just means a higher difference in En. In a bond situation, so like this, O remember for ions, it goes in brackets with the charge outside. You would represent, so if you're doing it with lines, this would be your delta negative side. This would be your delta plus side. Or if you want to use the arrow notation, this is your plus. So the arrow will point to the left. Only 3 questions that are going to be on geometry, it looks like. We're asked which of the following is bent, which of the following is pyramidal, which of the following is tetrahedral, which of the following is square by or octahedral, which of the following is trigonal, pyramidal, and so forth. As a reminder, this is a test. I do have this sheet, this right here on it. It doesn't tell you, there's one column missing on this, but bonded pairs, lone pairs, to give you some idea. This one has 1 lone pair that's hidden. This one has 1 lone pair that's hidden. This has no pairs, but 3 bonded pairs. You can figure out that missing column if you look at your homework or your things that pass it out. It's just a sum of these. This would have 3 total regions. This would have 3 total regions. 2 bonded, 1 lone. Basically, you draw the Lewis dot, count how many bonded pairs and lone pairs you have, and then match it with a table. And while I remember it, let me come in here and go ahead and change the En on the test. But I gotta do that for every single new test. So there are 6 questions where I give you the formula, ask you to write the name, and 6 questions where I give you a formula and ask you to, 6 questions where I give you the name and ask you to write the formula.
These are all covalent?
Yes, covalent. So just remember your mono, your di, your tri, your tetra, your penta, spelling out. Then your hexa, hepta, and octa. We use non for 9, and deca for 10. Mono is only used on the second element. The rest are used on both elements. So, for example, water's name. There's 2 hydrogens, so we do dihydrogen. And mono is always used on the second one, so it's 1 oxygen, so we do monoxide. Then, let's see. What's another good one? CH4, methane. So we always call this methane, but if you wanted to do it, we don't put, so this is 1 carbon. So carbon, but we don't put mono on the first one. And this would be tetrahydride. Which sounds really weird. That is the correct thing. Don't forget, we also use IDE. So even showing you. Again, I've only showed you on a high school level the very basic naming scheme. The IUPAC naming scheme is actually very, very advanced. You have certain groups or families of elements. The preferred name of this is methane. Because this is a family of chemicals, and this family of ANE ending chemicals, this is the preferred way of naming it. The systematic name is another way of naming this. This is if you just loosely follow the rules without any thought or reason. It's never recommended. It has a preferred name instead. But we do see that one of the rule systems is carbon tetrahydride. What is the name of this? What's the family? I'm just curious. So we have methane, we have propane. They're all under a certain family of gases. Meth, of course, means 1. Pro means... I don't even know what that's off. I'll look it up later. So then we have properties of our covalent and ionic. If you put it in water and it forms an electrolyte, what does that, first of all, what does that mean? Forming an electrolyte. Well, let me ask you this. Is that a ionic or covalent property? It's ionic. What does it mean to form an electrolyte when you put it in water?
on the salt.
Mm-hmm.
Well, it does.
Means it conducts electricity. Specifically, it means that it breaks apart into its ions. It disassociates into its ions. And then whenever you boil the water away, it leaves behind the salts. And the ions allow it to conduct electricity. That's why if you hear like you should be drinking your electrolytes, that means it's salts dissolved in water, so it broke apart and has ions floating around, and your body can, because the ions are free, somewhat free. You can use it to replace missing ions in your body. It basically says it has a lot of salt in it.
Only three that are essential, isn't it? It's potassium, magnesium, and sodium.
Sodium and potassium are needed for neurons. Anytime you want to send a signal from your brain to your arm, you're constantly regulating your potassium and sodium. And what was the third one you said?
Magnesium.
Magnesium sounds about right. Potassium and sodium, most definitely. You have a sodium pump and potassium pump in each cell.
What would happen if you just didn't consume enough daily electrolytes over time? What would happen?
Well, your body can, like, if you consume salt, your body can break the salt apart and make its own ions and get it.
So what if I just decided that I was going to eat nothing with sodium or anything?
So, you eventually urinate out a lot of salt. So your body is constantly having to maintain its pH levels and its salt content. If you get too much salt, you're going to concentrate and do through osmosis and a bunch of other stuff. Eventually, you'll need to excrete a lot of salt from your body. But if you stop consuming electrolytes, you're going to be losing more salt than as your body consumes it and uses it. So one of the first things will happen if you stop doing salt is muscle spasms. I don't know if you know this, but it takes your natural tendency of your muscles is to constrict as hard as possible. It's when you relax it, you're actually using energy to keep it in a relaxed state. It doesn't take much. But it's like a wrench system. It's like plugged up. You'd have to go through A&P and do all of that. It's like a ratchet system on the isomers or wherever it's called, the muscle fibers. That's why when you die, you get rigor mortis, and you're no longer able to move all your muscles. But if you start getting low on potassium or magnesium, you'll eventually have. I've had this on my foot.
Is that what you cramp?
Somewhat, yeah. I've had my foot go entirely vertical and pull around. It was extremely painful. It was the doctor thought that it was probably low potassium or something. But basically my tendon behind my foot just constricted as hard as possible and pulled my foot into an impossible position.
I've had terrible calf cramps overnight. And that's what they like say to eat a banana. Makes sense. It's like explains cramps.
I forget exactly what a cramp is, but I assume it's a temporary imbalance of you're needing potassium or something.
I'm sure my calf locks up.
Which of these is covalent?
CO2. Would be ionic.
Exactly. So you can go through the list of EN values, see which one are greater than 1.7. That's what I recommend you do. But you can also remember that ionic is usually a metal plus a non-metal, while covalent is often two or more nonmetals. Which of these are covalent and which ones are not?
Excuse me, teachers and students, for a quick interruption. There will be no track practice after school today due to the wet weather conditions. Thank you.
So let's start with the basic.
What's the first one?
The first one is what?
No, so
So we have a 2.2 and chlorine is about what? 3.5?
3.0 is what mine had.
3.0. Even if it was 3.5, that's 1.3. If it's 0.3, it's definitely covalent. All right. What about oxygen or ozone? This is ozone. O3, O2 is oxygen. O3 is, so O2 is molecular oxygen, O3 is that. What's the difference between the bond? EN difference? 0. Covalent. Non-polar covalent. Symmetrical between all three. Oh, we have this too. Covalent. And let me add a simple one. Let me add another simple one. Let's see if I can find one where it's... Can't find one without metal. There's at least 2 structures. They're most definitely not all covalent. So another thing about ionic is when 2 ions bind together. If you have 2 ions bonded together, it's ionic. What is the name of this formula? What is lithium? Lithium usually produces lithium ions. What about this coming after it? What is CO3? What is CO3? Carbonate. What happens when you put hydrogen in front of it? It becomes hydrogen carbonate, which we usually call bicarbonate. So we have a lithium ion and we have a bicarbonate ion. That should be just minus. So this is what we've done when in the ionic section, where we have 2 very strongly ionic ions. NH3. Well, what is N and what is H? So it's covalent. What about this one? Well, we definitely have 2 of these for 1 of these. It looks binary. What is this but ammonium? Or only positive polyatomic ion. And sulfur makes ions too. This would be sulfide. So this would be ionic.
Yeah, I don't really know what I was thinking the first time when I did the second one. I just carbon always in the middle and then compared everything to carbon.
So my point here is when going through ionic and covalent, if you have only 2 elements, it's simple. Look at it. If you have the same element but multiple of them, you know it's covalent. But if it's 2 elements, you need to go through and think about it. Or go through and do that little trick thing. If we end up having multiple ones, we're going to need to think, can we break this up into ions? Is this an ion that you remember? We know what this is. OH is hydroxide. So an ion always has 2 parts. Is this an ion? The only one that would match to would be acetate. Is the only ion we have that's very complicated. And it doesn't. Acetate is CH3CO2. It's close, but this has 2 hydrogens and this has 2 oxygens. So acetate is a common ion. But this is covalent. It's ethanol. I'm not going to have anything complicated like that on the test. But I might have something like sodium carbonate or sodium bicarbonate. We've gone over ionics, and you should recognize this is a cation, and this is your anion. You should be able to recognize common ions. Sodium, we have a very strong metal. The very strong metal should tell you that it's a ion. These things, CO3, HCO3, should tell you they're ions too. Two ions together tells you the whole thing is ionic. NH4 and CH3, I don't have acetate on the test, but these two are very common ions. These two are probably the only ones that don't have metal in it. Well, I'll say that. CO3 obviously doesn't have a metal. Inside of this, CO3 2 negative, this has covalent bonds inside of it. But it's ionically bonded to a sodium atom. Technically, it's done to two. These are ionic bonds. The outside bonds are ionic, so overall the molecule is called an ionic molecule. Does that make sense? Out of curiosity, so this can be written as like this, or it could be written as the empirical formula. This is what I believe is mostly written as. You could also even expand it as C2H6O. This is ethanol. It looks like this when you write out the formula. So this is the Lewis dot structure part. I say this is the Lewis structure. Usually when you get into more advanced, we leave off lone pairs. When we get into organic chemistry, lone pairs determine shape. I believe that by having this bent, you have the shape. Do y'all know what another way of writing this whole formula is? That's it. This right here has all the information right here. I'm thinking at the end of the year teaching y'all this notation too. Every intersection or every end point of a line is a carbon. So right here is a carbon and a carbon. And unless we have another molecule attached to it. But we have to complete the octet rule. So 1, 2, 3, 4. I need 5, 6, 7, 8. We add hydrogen to complete the octet rule. So we have 1, 2 here. So 3, 4, 5, 6, 7, 8. So the carbon is these two endpoints. This is not a carbon because it has an O next to it. It's really simple. I think that's basically the test, though. I don't think I have anything crazy where you have to remember carbonate. Most of them are just 2-element answers. Like 2 elements where you doing the 1.7 and 0.5.
Oh, yeah, that's good, isn't it? Thought so. Y'all like them? Yeah. I just did that.